Hi everyone, it's Sorkin. Welcome to my channel. Today we are going to solve LeetCode 160 intersection of two linked list problem. So the problem statement is that we have two linked lists, and with the head of the linked list being A and B, and we need to return the node at which the two lists intersect. So if there is no intersection between these two lists, we need to return null. As an example, we have here two linked lists, A and the B. So they are intersect at this point. So it means that the A2 and the B3, they are pointing to the same node. Another important requirement is that we need to retain original structure when we return in our return value, which means that we cannot modify our linked list. So yeah, that's it. Let's see how we are going to solve this problem. Okay, let's take our example that we have seen earlier and let's work on that. Let's say that we have A linked list and we have B here. So at some point they start to point to the same node. So they intersect and we need to find that. So this is B. B has one more node, and we need to, actually that's the problem that we exactly going to solve. If let's say that they have exactly the same size, let's say that we have only these two linked lists, they have exactly the same size. We start from the beginning and we move them simultaneously until we will get to the point where they are pointing to the same, where a node at A equals to node at B. So we are returning that. The problem is that the B is longer than A, so we need to move the A that difference times. So what I mean exactly by that, so let's say that the S1 linked list A has the size of S1, and the second one, B, is the size of S2. And the difference between them, S2 minus S1, is, in our case, is 1, right? In our case, it's equals to 1. Let's just call it variable D. So it means that we can we should move the B D times. Then after that, we are gonna start to move them simultaneously until these two linked list meets, which means that we find the intersection, which means that they are equal at that point. So we are returning this node, and since we are not doing any modification, as it is as it was one of the requirement, then so we can return it as a result. So that's it. Let's put this explanation to code. Okay, so first thing that we are gonna do, first thing first, let's check corner cases. If L1 is equals to null or L2 equals to null, so in that case, it means that there is no intersection. So we are gonna return, in that case, we are gonna return just null, right? So then after that, what we need to do, we need to calculate the size of L1, and we need to calculate the size of the L2 and compare them. So let's do that first. Let's say list node. Another thing that we need to do, we need to create a new node. In order to not to lose the pointer to the head, we need to create a new node that points to the head of L1 and to the head of L2. Otherwise, we will lose the head of the L1 and head of the L2. So what we are doing, let's call it L1 temp equals to L1, and another one is so for this one, we need to calculate S1 as we have seen in our explanation part. So S1, so while L1 temp, so L1 temp is not equal to null, then we are just move it, and L1 temp equals to L1 temp next. So which means that we are just moving that to the next node, and we are incrementing our S1. So we are incrementing that. So exactly the same thing we are going to do with the second node. So I'm just going to copy paste this code. So L2 temp, that's also should point to the L2. So otherwise we will lose the pointer to the head of the linked list for L1 and L2. So for the S2, we need to do exactly the same. So while L2 temp is not equal to null, L2 temp is equals to L2 temp to next. So we're just moving our pointer. And at the same time, we are incrementing S2 in order to calculate the size. Once we exit this loop, what we need to do, we need to see that, okay, if S1 more than S2, so what it means that the L1 is longer than L2. So in that case, what we need to move them exactly the difference, whatever is difference between D and S1 and the S2. So D is difference. Let's initialize that D is equals to S1 minus S2, right? So while D is not equal to null, so then we are gonna move that to that difference part. So it means that the L1, we are moving now the actual node. So L1 is L1 equals to next. So let's say that the size of L1 is 5 and the size of L2 is 3. So the difference is 2. So we need to move the L1 2 nodes. So at that point, they will have the same size, and we can move them together until we find the intersection. Okay, so and we are decrementing here our D difference. Okay, so exactly the same thing else. If not, then it means that the L2 is S2 is L2 is longer than S1. Then we are doing exactly the same, but in opposite direction. So we say S2 minus S1. So and we say, okay, while D is not equal to 0, do the following. The same like for D2. So L2, L2 next. So we are moving the to the next node for L2, and we are decrementing the D. Okay, so that's it. Once we exit this loop, they are so we move the difference, whichever linked list is longer. Now we have to move them simultaneously until we get to the intersection. So what we say, while L1 is not equal to L2, so which means that there is no intersection yet. So we say, okay, L1 is equals to L2, L1 dot next, and the same we should do for the L2. L2 equals to L2 dot next. Okay, and that's it. So after that, at the end, so we haven't modified our linked list, so we are just returning L1, and that is or we can return L2, doesn't matter. In our case, we are returning L1, so it means that this is the node, this is the intersection for these two linked lists. That's it. Let's check our code. Yeah, actually, let's initialize them here because they might not have been initialized. Let's do the same for S2. Okay, great. It works as expected. Let's go over algorithm one more time. So first thing that we do is we are calculating the size of for each linked list. So for the L1, it's a S1. For the L2 is a S2. After calculating the size, we compare. If the L1 is longer, then we find the difference and move the L1 exactly whatever that difference is. Exactly the same if the S1, if the L2 is longer, then we do exactly the same for the L2. And since at this point they are the same size, we are moving them simultaneously until L1 is equals to L2, then at that point we just return one of the linked list, because it doesn't matter L1 or L2 because they are pointing to the same node. Yeah, that's it. That's the solution for this problem. I hope you like my content. If you like it, please hit the like button and subscribe my channel. That's it for today. See you next time. Bye.